I'm going to be talking today about Innuendo. First of all, my name is Bas. I work for a company called Immunity. We're an offense-focused information security company based out of Miami, Florida. We've been doing this stuff for about 15 years now. So Innuendo is our implant framework, aka covert endpoint management, aka network implants backdoor. We designed it around two key concepts. We designed it to be flexible, which means it had to be rapidly adjustable to kind of changing network scenarios. And it had to be resilient, means it had to be completely fault tolerant and interruptible. So the core architecture, it's built on top of a covert Python 2.7 interpreter where we re-engineered a lot of the low-level bits and bobs to allow things like loading libraries from memory as opposed to loading from disk. We exposed the full standard Python API on the implant, both on the implant and the C2. It's fully asynchronous. The communication to the C2 is initiated by the implant using a dead drop-like protocol. And everything is, all the operations, all the operation modules are implemented on top of state machines that enable a minimal loss of state, so they're interruptible and resumable at any given point. So you can yank a wire, and a month later, if the thing comes back, it'll resume where it was previously, as far as data transfers and things like that. So main architecture diagram, the brains of the whole thing is the Innuendo C2. That exposes an RPC endpoint that the UI server talks to. The UI server provides the operator with a modern web UI. It's very fancy. And then in the back end, there's a PostgreSQL database that kind of maintains state for all the operations and does all the logging and timestamping and all that kind of stuff. The RPC endpoint is also fully scriptable by your operator, so they don't have to use the web UI. They can actually script against it using a Python API or actually a raw REST API. The actual implants communicate to the C2 over something we call the channel stack, which is a collection of communication modules. What those are, I'll get to in a little bit. The core idea behind Innuendo is that we wanted to have something that was hot patchable at runtime. So the implants can have their code updated at runtime without any process restarts for both the operation modules and the channel modules, which means you can actually send a new communication module or channel module to an implant and have it kick in, have the channel switch over to the new channel. So you can go from a DNS to ICMP to FTP to, hey, there's some very specific protocol on this network, which is the only protocol that's allowed out of the network. We implemented that protocol, and now we switch over to that. And then another component of the implant that we think is pretty cool is the Python Executor. So the Python Executor allows an operator to push arbitrary third-party Python to an Innuendo implant, have it run from memory, but still have transparently all the Innuendo encrypted transports and Innuendo encrypted data stores available to it. So you can run a random GitHub project with all its dependencies from memory, have fully encrypted comps to the input and output without actually having to invest heavily into engineering against the Innuendo API itself. So this lets you kind of rapidly stand up tool stacks on the endpoints and kind of adjust to network scenarios very rapidly using third-party tools and existing Python scripts and things like that. So this ability to leverage existing third-party libraries, not only does it prevent you from having to reinvent the wheel, it also allows you to rapidly change wheels, which is important when you talk about signature telemetry for behavioral things in your implant. So you can rapidly swap out big components of the implant without having to spend 4 or 5 months going through an engineering team. You can do this in a small team that all they need to know is Python. So it's easily, you can easily skill up your team to actually work with this implant. And then another thing that a lot of our customers use it for is exploration of kind of the problem space. Like, hey, what do we want our actual implant to do? So they'll use a framework like Innuendo to explore kind of the problem space, what works, what doesn't work, what do we need it to look like, what does it need to behave like, and then implement the thing that you actually throw over the wire in a specific engineering effort. So people use it like that as well. So Innuendo Channels, these are the communication modules. Like I said, the actual Innuendo protocol runs over a dead drop-like protocol, drop and pick up. All data transfers are completely resumable and fault tolerant. It's kind of a BitTorrent-like protocol, which means that you can have a large long-term data exfiltration run over multiple channels. They can be interrupted at any point, and if the machine goes away and then comes back a month later, a half a year later, whatever, that transfer will pick back up and resume where it was prior. So currently we offer DNS, ICMP, FTP, named pipes for internal network comms. They can all organize through the named pipes, pick one to actually exfiltrate out of the network through one of the other channels. IMAP, SMTP, Outlook, Web, and then Web through PowerShell. We also have the Python Executor module. We have to also have that available as a PowerShell model, so we can actually push PowerShell scripts as well, fully encrypted from memory. And then the cool thing about the channel stack is that the channels can fail over. So if one channel stops working, it gets blocked or whatever, it'll reach its synchronization threshold and fail over to the next available configured channel in the implant. Like I said, you can update and push those channels as you go along. So that's cool because you kind of get a round-robin resiliency in your channels and the way you get out of the network. Operations, so the operation modules are kind of the core functionality of the implant. It's all Python, so we have a core API, and then you can also write them in just regular Python, depending on how deep you want to package them with the implant. It comes with all the things that you want an implant to come with. We have an integrated exploit manager for local privilege escalation integration. You can take arbitrary LPEs, compile them as a DLL, and they integrate cleanly into the framework, again from memory, fully encrypted for deploying. Then we have the file manager for covert interaction with the remote file system, all the things that you would want it to do: upload, download, execute, enumerate the entire file system. We can load kernel drivers. You can inject DLLs from memory to memory, which is important. And you can inject Innuendo itself from itself into something else as well. So you can actually have multiple Innuendos on the system, all coordinating comms and privilege management on the system. All the recon modules, audio recording, key logging, network sniffing, registry editing, credential management through Mimikatz, that kind of thing. And then we also expose the full WMI API, so you can do your covert network administration the way you're used to using the WMI interface, get all the process event monitoring and all that kind of stuff. Like I said, the RPC is, the C2 is fully RPC scriptable, which means you can do pretty sophisticated behavior on top of the Innuendo framework using the operations. You can do if this, then that type stuff. So an example of that is monitoring process events, saying like, if process A appears, launch operation B, and you can get arbitrarily complex with that. Persistence, big subject to get in here on stage in 10 minutes because this is a whole bunch of code. We've been working on it for about 6 years. But in a nutshell, we offer a domain-specific language that allows you to specify persistence recipes. And for example, do this binary plant, install this service, do something like this. But the idea is that you maintain a massive library of persistence methods, and you can tailor those persistence methods to the endpoint. Again, that gives you diversity of behavioral signatures. So having this persistence framework gives you a massive amount of flexibility in how you persist on the endpoints, and not having something that's baked into the implant itself. You can actually take this out of the framework and integrate it into your existing tool chains and have a separate team develop persistence methodologies for you. Everything runs from memory. When we can encrypt, we do encrypt, is the TLDR. So if you have any questions, I'm almost out of time. Please contact me at boss@immunoinc.com or hit me up here. I'll be running around all day. I have a laptop on me if you want to see it a little bit closer. Thank you.